Today's lab, what we're supposed to do is we're supposed to titrate sodium hydroxide and standardize it, and then titrate acetic acid with the standardized sodium hydroxide, figure out its concentration, and then ultimately we want to determine the pH of the acetic acid solution, aka vinegar. So there are three objectives today. First objective is to standardize the NaOH with KHP. Second thing is to determine the concentration of acetic acid, vinegar. The third part is to determine the pH of the acetic acid solution using the concentration that you determined in part 2 of this experiment. So standardizing the sodium hydroxide is what we're going to discuss right now. Sodium hydroxide is going to react with KHP, and a neutralization reaction is going to form water plus the salt. And so KHP is not potassium hydrogen phosphorus, it's potassium hydrogen phthalate. You will have to look up the molar mass of this compound. Don't assume that it's potassium hydrogen phosphorus, you'll get this wrong. So what we want to do is we're going to know the mass of the KHP used, and all this information will be provided to you on Moodle. So you're going to know the mass of the KHP. Now, the nice thing about this particular reaction is that it's a 1:1:1 ratio all the way across. So we're going to take the mass of KHP, we're going to convert this and figure out the moles of KHP. Then we're going to use the mole ratio to figure out the moles of NaOH. So our goal here is to solve for the concentration of NaOH. To do this, what we need to do is we need to know first how many moles of NaOH we reacted with, which is coming from this calculation here. And then you need to know the volume of liters used of sodium hydroxide. That comes from the readings on the burette that you're going to be provided in just on Moodle. So you take your moles, NaOH, divide it by the volume of liters used, and that will figure out the molarity of the NaOH. Now you have the first trial, then you'll have the second trial. And what you want to do with these two trials is you want to average them out to get the average molarity for your NaOH. So that's part 1. Part 2 is going to be solving for the molarity of acetic acid. All right, to do this, we'll take the first thing we're going to do is we'll write out the balanced equation. So we're going to have acetic acid reacting with NaOH, going to form your salt plus water here. So you'll have to make sure you balance this equation here before you go further here. So now what we do know from the titration is we know the volume of milliliters for sodium hydroxide. So what we want to do is we want to convert this volume from milliliters into liters of sodium hydroxide used. So then we'll take the molarity that we just solved for with sodium hydroxide in part 1, and we're going to figure out how many moles of NaOH we use to titrate. Then we'll take the moles of NaOH, we'll convert the moles of NaOH into moles of acetic acid, and that comes back to the balanced equation that you should have done already. So once we figure out the moles of acetic acid, then we can solve for the molarity of the acetic acid. And so to do that, you're going to take the moles of acetic acid and you're going to divide it by the volume of in liters of acetic acid used. Again, this will be provided to you on Moodle in a picture. So all your data that you're going to obtain from this is going to be given to you on Moodle in a picture format, and you'll see all this in a Word file as I post it on Moodle. So use that Word file to your advantage as you go through these calculations. So that's part two. Part two is determining the molarity of the acetic acid. Now, we've learned in class that acetic acid is a weak acid, and so what we want to do now is we want to calculate the pH of the acetic acid solution. Vinegar, in fact, this is what we have been titrating. So we're going to figure out the pH of the solution that's inside of this bottle. Now, this goes back to what you've already done and learned how to do in lecture, and that is working with the equilibrium. All right, so determine the pH of vinegar, also known as acetic acid. So we know acetic acid is a weak acid. Going to form an equilibrium to produce acetate ions plus hydrogen ions. So this goes back to the ice chart. All right. So what you're going to need to do is you're going to need to use your textbook. You're going to need to look up the Ka value for acetic acid. First thing you need to do. Second thing you need to do is you need to make sure you go back to part two, figure out the molarity of the acetic acid, and then you'll fill in this ice chart just like we talked about in the lecture. And so once you filled in your ice chart, then you're going to set up the equilibrium expression. All right, we're going to look the K value up. All right, so the equilibrium expression is going to be as such. So what you're going to do, you're going to take the information from the ice chart, you're going to plug it in, you're going to use the quadratic equation to solve for x. All right. So once you solve for x, you're going to find out from the ice chart that x is equal to the hydrogen ion concentration. And then what you can do is you can solve for the pH. Remember the equation for pH is pH is equal to negative log of the hydrogen concentration. And so that's the objective for this experiment. Remember, there's three parts to it: standardized sodium hydroxide using KHP. The second part is to determine the molarity of the acetic acid. And the third part is to ultimately determine the pH of this solution.